So imagine this. You've got a public health analyst, they're slammed, they're up against a deadline. They do what a lot of us would do. They copy a huge chunk of surveillance data, paste it into ChatGPT, and say, summarize the trends for me. And what they get back, it looks perfect. I mean, it's clear, it's confident, it's packed with specific numbers. It just sounds right.
But here's the catch. Buried deep in that beautifully written summary is a statistic that is completely made up, a confident, well-written fabrication. And that right there is the central paradox of using large language models, or LLMs, in a field like public health. The output can look smarter and cleaner than a human's first draft, but you just can't trust it without checking every single detail.
So to figure this out, we're going to break it all down. We're going to look at what these models actually are, see where they're already being used in public health today, dig into why they fail in such spectacular ways, and, most importantly, how we can deploy them responsibly. You know, the question isn't if public health is going to use LLMs. That's already happening. The real question is, are we going to use them well?
Okay, so first things first, what in the world is a large language model? Let's pull back the curtain and demystify some of that magic.
At its absolute core, an LLM is a pattern completion engine. That's it. It's been trained on just an unimaginable amount of text, and its entire job is to predict the next most statistically likely word in any given sequence. Now, the secret sauce that makes this so powerful is an architecture called a transformer. It uses this clever mechanism called attention to figure out which words in your prompt are the most important, and that lets it generate text that feels incredibly coherent and aware of the context.
And this is the most crucial point to get. LLMs do not understand language the way we do. A person, a human, reasons from first principles. We verify facts, we grasp the true meaning behind the words. An LLM, it just mimics coherence. It generates statistical patterns that it learned from all that text it was trained on. Now, when those patterns line up with reality, the results are brilliant. But when they don't, you get really convincing nonsense.
Now, keeping that pretty major limitation in mind, you might be surprised to learn just how widespread these tools already are. We're not talking about some far-off future technology for public health. LLMs are already embedded in workflows, and they're making a measurable impact right now.
And the applications really cover a huge range. On one end, they're summarizing these super dense reports or pulling key data out of electronic health records in literally minutes. And then on the other end, they're being used for clinical decision support, for speeding up literature reviews, and even powering public-facing chatbots for huge organizations like the WHO, all to make complex health guidance way easier for everyone to understand.
But, and this is a really big but, every single one of those powerful applications comes with the exact same fundamental risk. We have to talk about the hallucination problem.
Just look at this number. It's staggering. Some research has found that anywhere from 15 to 30% of factual claims you'll find in health content generated by LLMs can be completely fabricated. They sound authoritative, they look right, but they are just plain wrong.
And this happens for that exact reason we talked about earlier. LLMs predict the next word. They don't retrieve facts from some perfect database. They just generate what sounds like it should come next, based on all the patterns they've learned. So why is this especially dangerous when we're talking about the health of entire populations?
Well, it really boils down to three core dangers. First, the scale of the impact. A single wrong statistic in a summary report could cause an entire region to misdirect its resources. Second, there's the expertise gap. Sure, an expert might spot a wildly incorrect number, but a more subtle, plausible-sounding error, that could easily slip past a non-specialist. And third, and this one is scary, is error propagation. Once a hallucinated data point gets into a report or a dashboard, it can just spread through all your other systems, totally laundered of its sketchy origin.
And this isn't just a theory, by the way. A landmark study in Nature Medicine really highlighted this. They found that while a particular AI model was actually very accurate on its own, when doctors used that same model as an assistant, their overall diagnostic accuracy didn't improve at all. That tells you the problem isn't just about the model itself. It's about that critical, tricky interaction between the human and the AI. So how do you actually use a tool that is so incredibly powerful, yet so fundamentally unreliable? Well, you build guardrails, and you have to treat them as absolutely non-negotiable.
Here are 4 essentials. First, HIPAA compliance. This isn't a suggestion. You never, ever upload protected health information to a public tool. Second, prompt engineering. Learning how to ask the model the right questions matters immensely. Third is a real game changer. It's called Retrieval Augmented Generation, or RAG. This is huge. It basically connects the LLM to a verified, trusted knowledge base, forcing it to base its answers on real documents, which dramatically cuts down on hallucinations. And finally, the most important one of all, human-in-the-loop validation. A qualified person has to review every single output, period. No exceptions.
And on top of all this, you have to know that the regulatory world is catching up. New rules like the EU AI Act and new frameworks from the FDA are starting to classify health-related AI as a high-risk technology, which means they're going to demand transparency and human oversight. So public health teams have to navigate this very, very carefully.
All right, so where's this all heading? Let's take a quick look at what's on the horizon for LLMs in the health sector.
We're seeing more and more specialized models like MedPalm, which are fine-tuned specifically on medical data, and they're already outperforming the general-purpose models. The next generation is going to be multimodal, meaning they won't just integrate text but also images, lab values, even genomic data. They're also going to become powerful accelerators for research, helping scientists generate hypotheses to test. And of course, this all means that the workforce needs new skills. Prompt engineering and output validation, these are quickly becoming core competencies.
So what's the ultimate takeaway from all of this? I think it's that LLMs are amplifiers. They amplify competence and they amplify carelessness. In the hands of a team that really understands their limits and builds the right guardrails, they can be revolutionary. But if they're treated as these infallible oracles, they introduce brand new risks at a massive scale. The technology itself isn't the variable here. The human discipline around it, that is everything.